It is finally time to define radian measure. Yay! So at the top of page 6, we have this big box that explains what radian measure is. So let's just read through it. Okay, so it says, for a circle of radius r, a central angle of theta radians that subtends an arc whose length is s is defined as theta is equal to s over r. Okay, so let's pause for a second. Remember where that's coming from. Okay, we know the arc length formula is s is equal to r times theta, and theta is your central angle. It has to be measured in radians. So remember, we are talking about angles. Okay, angles can be measured in degrees or radians, and we're trying to look at this from a radian perspective. When you're dealing with the arc length formula, the angle theta has to be in radians. So where this little statement right here is coming from is we've taken the arc length formula and solved for theta. Okay, so on the right side of the equation you have r times theta. If you want theta by itself, you just need to divide both sides by r. Okay, and that's where this statement is coming from, that theta is equal to s over r. Okay, so let's continue reading. Okay, that's the first thing you've got to realize. Okay, all right. So in other words, a central angle theta measured in radians is the length of the arc it intercepts divided by the radius of the circle. Okay, one more time. In other words, a central angle theta measured in radians is the length of the arc it intercepts divided by the radius of the circle. Because S and R are both measurements of length and have the same units, the units cancel out when calculating theta equals S over R. Therefore, a radian is a pure number, meaning that no units are needed. Okay, we've talked about that statement already, okay, a few times. Okay, just remember, it's just clearer now. Okay, theta is the arc length, which is measured in units of length, divided by the radius, which is also measured in units of length. Okay, so the units cancel out and just leave you with a number. Okay, while the term rad may be used, if no units are mentioned in describing an angle, it is understood to be measured in radians. Okay, we've also talked about that statement. Okay, it is imperative that if you are dealing with a degree number, okay, so if you've got an angle and it's measured in degrees, you had better put that degree symbol on there, because if you don't, the angle may be interpreted as a radian measure. Okay, so if it's degrees, you better put the degree symbol on it. Okay, if you encounter an angle at any time that has no degree symbol on it, it's just a number, it's understood to be measured in radians. Okay, so this next visual is very telling. Okay, this is a comparison of an angle of 1 radian and 1 degree. Okay, let's start with 1 degree, which is on the right, okay, because we're more familiar definitely with degrees. Okay, so if I'm looking at this picture right here, okay, remember, we're talking about a circle. Everything's in terms of a circle right now. Okay, so we know that if we have a circle, no matter what the radius is, okay, the circle is comprised of 360 degrees. Okay, so if you took the 360 degrees and you divided them up into, you took the full 360 degrees and you divided it up into 360 equal central angles, okay, one of those angles would measure 1 degree. Okay, so what I have here, okay, in this particular picture is we have a central angle and I have drawn in 1 degree. It's extremely tiny because it's only 1/360th of a revolution. Okay, so 1 degree is very tiny. But if you look at the picture on the left, the central angle is 1 radian, and you can see 1 radian is much larger than 1 degree. Okay, so hopefully this picture on the left will help you understand what a radian measure is. Okay, so essentially I'm trying to compare apples to apples. I essentially have the same circle with whatever radius you're using. Okay, we don't have a specific radius on here. Okay, so we've got a central angle. Okay, you've got the two rays that make up the angle. Okay, so the distance from the center to either point on the circle is the radius. Okay, so this is the radius, this is the radius. Okay, so what an angle of 1 radian is, okay, so whatever your radius is, however big that is, if you start with your angle in a standard position here, okay, and you trace along the curve, and you walk, say you're starting right here, okay, so your initial side coincides with the positive x-axis, so you start right here and you start walking along the circle, okay, say you walk r units, so you're walking a distance equal to the radius of the circle. Okay, so once you walk that distance equal to the radius of the circle, you stop. Okay, and so then your angle is going to be drawn through those 2 points. Okay, so your first ray is going to go from the center of the circle to your initial starting place. Okay, and then the second ray is drawn from your vertex to your stopping point. Okay, and it creates this angle. Okay, which is, in this drawing, it is positive because you're walking in a counterclockwise direction. Okay, so what's happened here is your arc length, this distance that you've walked, is equal to the radius. Okay, and the angle that results is 1 radian. Okay, so let me show you something else to possibly clear this up for you. Okay, what do we know? We know the arc length formula. Okay, we know that S has to equal R times theta. Okay, well, when we examine this picture, look at this yellow distance. The measure of this yellow distance is R. So the arc length here is R. So I'm going to replace S with its value R. So this equation turns into R equals R times theta. Okay, now remember, we're trying to solve for theta here. We're trying to think about how big theta is in radians. So if you look at R equals R times theta, we can divide both sides by R, and then on the right side, the R's will cancel. So R divided by R is going to leave us with theta. And then on the left side, R divided by R is 1. Okay, so in using this formula, theta has to be measured in radians. So this, by doing this little calculation here, hopefully this kind of makes it a little clearer that by, drawing your picture this way, where the arc length is equal to the radius, that is subtending an angle of 1 radian. So that is what an angle that measures 1 radian is. Okay, I've kind of got it explained in the wording below. Okay, it tells you that 1 radian, which you can write as 1 rad, it is the central angle of a circle whose arc length is the same as the radius of the circle. In other words, 1 radian is the central angle formed by laying the radius of the circle onto the circumference. Okay, that is extremely important. Okay, right there, that statement tells you what a radian is. Okay, I'm going to highlight it in yellow because it is super important. So if you're going back through your notes, you want to remember this. Okay, radians are all over this class. Okay, radians will be all over pre-calculus. Radians will be all over calculus. Okay, you've got to understand what a radian is. Okay, this schematic is very telling. Okay, if you are trying to compare 1 degree to 1 radian, here it is. Okay, so you've got to remember, how do I form an angle of 1 radian? Okay, well, you have your starting point. Okay, you're in standard position. You start walking. Just visualize yourself walking along the circle. Okay, you're going to walk from your starting point. Okay, you're going to walk a distance of are units. You're going to walk the length of the radius and you stop. And that's how your angle is formed. Okay, and that angle measures 1 radian. Okay. All right, so remember that statement that I've highlighted in yellow, okay? And remember how 1 radian compares to 1 degree, okay? 1 degree is much smaller than 1 radian, okay? 1 degree, which again is notated as 1 degree, it is just 1/360th of a revolution, okay? So commit this to your brain, this picture, okay? How does 1 degree compare to 1 radian, okay? And this is true no matter how big the circle is, no matter what your radius is, okay? This picture is going to hold no matter how big the circle is, how big its radius is, okay? So these are the 2 most popular ways to measure angles, degrees or radians, okay? They're just different ways of representing an angle, okay? So now what we're going to talk about is how do you convert between the 2, okay? If I've got a degree measure and I need it in radians, how do I do that? How do I change over from degrees to radians? Or vice versa. If I have something in radians and I need to change it over to degrees, how do I do that, okay? Well, the thing we need to do, we're going to come up with some conversion factors, okay? So on the next page, what we're going to do, and this is going to be a biggie, we know 360 degrees are in a circle, so the question is going to become, how many radians are in one circle? Okay, let's take a look at the next page.